हेलो एवरीबॉडी। आज हम इस वीडियो में देखने वाले हैं नेक्स्ट पॉइंट्स ऑफ न्यूक्लियर केमिस्ट्री टॉपिक। दिस वीडियो इज सेकंड पार्ट ऑफ न्यूक्लियर केमिस्ट्री। ओके, इन फर्स्ट पार्ट व्हाट वी सी, वी कवर सम बेसिक्स which are important for understanding nuclear reactions. Also see about nuclear reaction and energetics of nuclear reaction. तो आज हम देखने वाले हैं इस वीडियो में टाइप्स ऑफ न्यूक्लियर रिएक्शंस। टाइप्स ऑफ न्यूक्लियर reactions. So there are different types of nuclear reactions: artificial transmutation, artificial radioactivity, nuclear fusion, nuclear fission, projectile capture reaction, projectile capture particle emission reaction, and so on. Okay, so we see one by one. From this, first we start first reaction, that is artificial transmutation, or it is also known as artificial disintegration. So what is mean by artificial transmutation or artificial disintegration? So that transmutation, when done by artificially, means then it is known as artificial transmutation. Transmutation when done by artificial means, then it is known as artificial transmutation or artificial disintegration. Okay, if non-radioactive nucleus having medium mass is bombarded by high-speed projectile, when non-radioactive nucleus when bombarded by high-speed projectile produces a nuclei of new element called daughter element or recoil nucleus. Then this process of atomic transmutation is known as artificial transmutation. So who discovered the artificial transmutation? The first artificial transmutation was recognized, described and reported by scientist Rutherford. Remember that. When? In 1919. So who discovered the artificial transmutation or artificial disintegration? Scientist Rutherford. Okay. So how he discovered? Non-radioactive nucleus, that is nitrogen having mass number 14, when bombarded by high-speed projectile, that is alpha particle, then there is formation of recoil nucleus, that is oxygen having mass number 17 with emission of one proton. Okay, so similar disintegration was observed by Rutherford and Chadwick also for all elements between boron and potassium. Okay, so using projectiles like alpha particles, protons, neutrons, deuterons, gamma rays, various transmutation are carried out. We see one by one. So first we see transmutation by alpha particle. First, transmutation by alpha particles. So in this different processes are present. First process is alpha N process, means projectile is alpha particle and emission is neutron. So we see one example. For example, beryllium 49 when bombarded by alpha particle, then there is formation of which recoil nucleus. How we find? Their emission of which one? Neutron. So plus N01. Here atomic number 4 plus 2 is equal to how many? Here minus 0. 4 plus 2 6 minus 0 is equal to 6. So which element having atomic number 6? That is carbon. Therefore carbon 6, and mass number 9 plus 4 is equal to 13, and here minus 1, that is 12. So beryllium 49 when bombarded by alpha particle, then we get the daughter element carbon 612. Okay, then alpha proton process. Alpha proton process, we see in starting one example, that is nitrogen element when bombarded by alpha particle, then proton is ejected, and which one is daughter element? Oxygen 817. We see another example, that is fluorine having mass number 19. Here projectile is alpha particle, that is He24. Then there is formation of, here emission is a proton, that is H11. So how many atomic number? 9 plus 2 is equal to 11, minus 1 is equal to 10. So the element having atomic number 10 is neon, and mass number 19 plus 4 23, minus 1, that is 22. So we get the recoil nucleus neon 1022. This one is transmutation by alpha particle. Then we see next transmutation by deuteron. Okay, so here D alpha process. So for example, when nitrogen 714, so we complete that nuclear reaction. Deuteron means isotope of hydrogen, that is it is H12. Okay, there is emission of alpha particles, means He24. Then 7 plus 1 is equal to 8, minus 2 is equal to how many? 6. Carbon 14 plus 2 16, minus 4 how many? 12. Therefore mass number 12, means we get the daughter element carbon 612. Okay, carbon 612. This is the one example. Now we see one more example of D alpha process, that is lithium 36 plus H12, here alpha He24. 3 plus 1 4, minus 2 2. So 2 means which element? Helium. 6 plus 2 4, 6 plus 2 8, minus 4 4, means here we get the 2 alpha particles, 2 helium. Okay, we can, it also can be written as twice of He24. Okay, Then next process is DN process. DN process. So example of DN process is aluminium 1327 plus deuteron H12. Okay. Here emission of neutron N01. Atomic number 13 plus 1 14. So which elements having 14 atomic number? That is silicon. And mass number 27 plus 2 29 minus 1 is 28. So this is the transmutation by deuteron. Then we see next, that is third transmutation, that is transmutation by proton. Transmutation by proton. Here we see one process, that is P alpha process. P alpha process. So for example, beryllium 49 is bombarded by high speed projectile, that is proton H11. Then here emission of alpha particles means plus He24. So here 4 plus 1 5 minus 2 3. So 3, which element having atomic number 3? That is lithium. 9 plus 1 10 minus 4, how many? 6. Okay. Then here next, transmutation by neutron. For this one process, that is N alpha process. N alpha process. For example, boron 510 plus N alpha neutron, emission of alpha He24. Here also 5 plus 0 5 minus 2 3, that is lithium. 10 plus 1 11 minus 4, that is 7. Lithium 3 7. Or another example is, second example, oxygen 816. Find out the recoil nucleus. Which recoil nucleus we get? So when oxygen 816 is bombarded by neutron, then emission of alpha means He24. 8 plus 0 8 minus 2, that is 6, means which element? Carbon. 16 plus 1 17 minus 4 means 13. And last transmutation is transmutation by gamma rays. Here gamma N process. Gamma N process. Okay. So example is beryllium 49. So when beryllium 49 is bombarded by high speed projectile, that is gamma, then there is formation of, here emission of neutron. Here gamma 0 0. So 4 plus 0 4 minus 0 means 4. We get beryllium. But mass number change. 9 plus 0 9 minus 1 8. Beryllium 4 8. So these are some transmutation. Okay. So next type of nuclear reaction is artificial radioactivity or induced radioactivity. So before starting the artificial radioactivity, first we see what is mean by radioactivity. What is mean by radioactivity? Definition of the radioactivity. So definition is, during certain nuclear reactions, spontaneous, continuous spontaneous, continuous, active radiations are emitted. Active radiations are emitted, called radioactivity. Okay, what is the definition of radioactivity? During certain nuclear reactions, spontaneous, continuous, active radiations are emitted, are known as the radioactivity. Now we see what is mean by artificial radioactivity or induced radioactivity. So the process of artificial atomic transmutation, artificial atomic transmutation producing radioactivity, is known as artificial radioactivity or induced radioactivity. The process of artificial atomic transmutation producing radioactivity is known as artificial radioactivity or induced radioactivity. And isotope emitting the radioactivity is known as the radioisotope. So what is mean by isotope? The element having same atomic number but different mass number are known as the isotopes. And if same mass number and different atomic number, then it is known as the isobars. Okay, remember that. Here in this case it is known as the radioisotopes because it producing the radioactivity. Okay, so artificial radioactivity was first discovered by scientist Irene Curie-Joilot and her husband F. Joliot. When? In 1934. So you may ask question on that. Who discovered the artificial radioactivity? Artificial transmutation was discovered by Rutherford and artificial radioactivity was discovered by Irene Curie-Joilot and her husband F. Joliot in 1934. So how he discovered? When aluminium is bombarded by alpha particle. When bombarded by alpha particle, atomic transmutation occurs with emission of neutron. Here neutron was emitted, and which element is formed? 13 plus 2 means 15, phosphorus 30. But in addition to neutron, the emission of positron was also observed. In addition to neutron, there is also emission of what happened? Positron was also observed, which is continued even after the source of that alpha particle was removed but decreased with time. देखो यहाँ क्या हुआ है? When alpha particle is bombarded on aluminum 1327, then there is emission of neutron takes place. But with that neutron, also one more particle is emitted, that is positron, and which is continue even after ये जो सोर्स है, ये जो प्रोजेक्टाइल है, ये रिमूव किया, फिर भी ये पॉजिट्रॉन सम टाइम के लिए क्या हुए हैं? इमिट हुए हैं, बट डिक्रीज्ड विथ टाइम. सो दिस इज द अनस्टेबल phosphorus 1530 is unstable and it emit positron. Okay, so which product is obtained in that reaction? 15 minus 1 is equal to 14. So 14, which element? Silicon, and mass number is 30. Here we get not phosphorus but silicon. This is known as the artificial radioactivity. Okay, so another definition also given by scientists. The artificial radioactivity may be defined as the process converting the common stable nuclei of atoms by artificial transmutation into unstable radioactive nuclei which decay at their own rates. So another definition, artificial radioactivity may be defined as the process converting the common stable nuclei of atoms by artificial transmutation into unstable radioactive nuclei which decay at their own rates. Okay, understand? So emission of that positron or electron is depend on that unstable radionuclide. How it depends? Generally, elements having lower atomic weights than their usual atomic weights emits positron, while those having higher atomic weights than their usual atomic weights emits what? Electron. Here in that reaction, phosphorus having how many atomic weight? That is 31. Here we obtain 30, means lower atomic weight than their usual atomic weight, hence it emits what? Positron. If higher atomic weight, then it emit electron. Okay, understand? Remember that. Then we see different process, different action, bombardment different. First, alpha particle bombardment. Okay, so first example, when boron 510 is bombarded by alpha particle He24, there is emission of neutron N01. Then there is formation of which unstable radioactive nuclei? 5 plus 2, 7, means nitrogen. 10 plus 4, 14 minus 1, 13. Nitrogen, 7, 13. But this one is unstable. So here star is represent on that. So nitrogen having usual atomic weight how many? 14. So here 13 is obtained. So it is lower than usual atomic weights. So it emits what? Positron या electron? It is lower, hence it emits positron E10. And what we obtained a final product? 7 minus 1, 6 carbon, 6, 30. Okay, this is next example. For example, magnesium 1225 when bombarded by alpha particle, then emission of proton 12 plus 2, 14 minus 1, 13. 13 means aluminum. 25 plus 4, 29 means here 28. So aluminum having usual atomic weights how many? 27. Here we obtained 28. Here higher than their usual atomic weights, means this unstable aluminum 1328 emits positron या electron. So it emits electron, E minus 1 0, it emits electron. Here we obtain here 13, here minus 1. So if we take here 14, then both sides are balanced. 14 minus 1 13, here only 13. So element silicon 28. Okay, so this is the alpha particle bombardment. Then next, proton bombardment. Proton bombardment. So we take one example. Then carbon 612 proton bombardment. Okay, then what we get? Nitrogen 713, which is unstable. Okay, unstable. Here nitrogen 713 means lower atomic weights, therefore it emits positron, and we get the final product carbon 613. Okay, also another example, sodium 23 plus proton, emission of neutron. Then here 12, magnesium, here 23, unstable. But magnesium having how many usual atomic weights? 24, lower atomic weights, therefore it emits positron, and here we get final product sodium 1123. The next one is deuteron bombardment. See, deuteron bombardment. So for example, boron 511, deuteron H12, here emission of proton H11, and if we get 5 plus 1 6 minus 1 means 5 boron, 11 plus 2 13 minus 1 12. Okay, unstable. This boron 512 having higher atomic weight than their usual atomic weight, hence it emits electron. So here 5, therefore here 6, carbon 6 12. Okay, so this one is alpha particle bombardment, proton bombardment, deuteron bombardment. Now we see neutron bombardment. D, neutron bombardment. So for example, for neutron bombardment, sodium 1123, neutron bombardment N01, so it is converted into sodium 24, which is unstable, so it emits higher atomic weight. Sodium having how many atomic weight? No, usual 23, here 24, therefore it emits electron, and we get final 12, means magnesium 24. Okay, and last one is action of gamma rays. Action of gamma rays. So for example, phosphorus 1531 plus gamma, here emission is of neutron. So 15 phosphorus and here 30, but phosphorus having usual atomic weight 31, therefore phosphorus emits what? Positron. Silicon 30. Okay, so here we completed the artificial radioactivity. I hope you understand the points which are studied in this video. If you have any doubt, please comment in comment box. Subscribe my Swapnali Yes Jadhav channel for such videos which are surely useful to you. Okay, like my videos, share to your friends also. Thank you very much. Okay, bye bye, and फिर मिलेंगे in next video.